I'm Brooke Zacharuk, and this is my presentation of my senior project. The title of my research is Increasing the Use of Earth Walls in Cold Climates to Create Healthier and More Sustainable Homes. It is estimated that the built environment contributes to 1/3 of global greenhouse gas emissions and consumes 40% of the world's energy. Additionally, indoor air quality is ranked as one of the top 5 risks to public health. Consequentially, typical construction is harming us and our environment as we continue to rely on man-made materials instead of using natural technologies such as earth walls. What are earth walls? The diagram on the left shows a section of an earth wall. From outside to inside, earth walls are essentially a layer of plaster on mesh, a layer of earth mixture, and a layer of insulation filled between wood studs. The diagram on the right shows how earth walls are integrated into typical construction. The yellow areas show the untypical areas in which earthen technology is applied. Essentially, only the interior wall assembly needs to vary with earth construction. All floor, roof, and ceiling assemblies can be built with typical building techniques. Why use earth walls? Natural construction methods that rely on the earth as a primary building material are proven to have zero carbon footprints and have minimal to no effects on occupants' health and well-being. Natural construction practices are popular in warm areas of the world, but are minimally used in cold climates. Because earth construction is not typically used in cold climates, this research sought to find the barriers that are inhibiting the natural technology. I interviewed large residential development companies to find out why they aren't using earth construction. The research found that large residential development companies thought that cost, construction process, and aesthetics were the main areas of concern related to natural technologies. The interview participants thought that earth walls would be more expensive. However, the materials used in earth construction are actually less expensive. Furthermore, if the material became standardized and written into the building code, economies of scale could also help bring costs down, as the use of earth would arguably decrease. It was also found that there were many concerns with the construction process. A few of these concerns were what kind of trades would be used. Can you build outside year-round? Are your mechanical systems integrated? There are many points that could address their concerns. Earth construction is easy to teach and to learn, so there may not be a skilled trade required. Walls can be built year-round with a prefabrication model, and there are multiple case studies that can show how modern mechanical, electrical, and plumbing fixtures can be integrated. Lastly, large residential builders said that people value conformity. It was said that people want a Martha Stewart interior. The first option to address this problem is that earth walls could be designed to replicate the appearance of typical construction. The other option is to highlight the natural technology by using the appearance inherent to earth walls. As you can see in this image, this does not mean that buildings need to be ugly or primitive. The interior wall in the background is quite beautiful and modern in its uneven and natural appearance. The research concluded that perceptual barriers were mainly impeding earthen technologies in cold climates. There is not enough awareness of the benefits of earth walls, and there is a misconception of the appearance and function earth walls can present. It was concluded that to increase the use of earth walls in cold climates, large residential development companies would need to start building with the technology because they have the most control over the public's perception. Lastly, the material needs to become standardized and written into the building code to alleviate restrictions surrounding the material. For next semester, my project will focus on developing a model home template that shows how earth walls do not require any functional or spatial sacrifices compared to homes built with typical construction. A 2-story, 2,000 square foot home will be built to show how earth walls could be applied in a large residential development setting. The project will focus on exploring the main issues large residential development companies had with earth walls: cost, construction process, and aesthetics. These issues will be addressed with design solutions to help show that earth walls are a viable building option in cold climates. 3 of Minto's 2,000 square foot models were analyzed to determine the functional and spatial requirements that the market demands from a house of this size. This information was used to develop the rooms and size requirements for the model home I will design. Additionally, based on the analysis of Minto's Bronte model, the rooms requiring plumbing are not grouped together horizontally, nor are they stacked vertically between floors. Additionally, the heat source is on an external wall and is not centrally located. Based on my research, I have concluded that these elements would need to be changed to accommodate earthen construction. These adjacency diagrams show how systems will need to be stacked vertically within the model home. Plumbing needs to be stacked from floor to accommodate plumbing stacks within the walls, which can be seen on the drawing on the left-hand side. The drawing in the middle shows heating integration. Radiant floors will be used on the first and second floors, and a central heating system, like a fireplace, will be used in the center of each floor to capitalize on the thermal heating capabilities inherent to earth construction. Lastly, electrical chases need to be pre-planned within all the walls to accommodate wiring. A junction point will also need to be applied on each floor to easily run wires between stories and to facilitate the maintenance of the electrical systems. Thank you for listening to my presentation.